In this lecture, we're going to be looking at the similarities and differences between references and pointers. Okay, we know that a pointer is really something that is going to store the address of a variable, and we can go through that pointer and modify the original variable or really do things with it. But in the last lecture, we saw that we could also do the same thing with references. So why have these two mechanisms in place, and what are the differences between them? Here is a simple slide that I put together to put the important points about references and pointers together. The first thing is that if you use references, you are not going to go through the star symbol to the reference and get to the value you are manipulating. So that's going to really feel like you are using the original variable. But with pointers, you are going to go through the referencing. So that's the first difference. Another thing about references is that you can't change them to reference something else later. But with pointers, we saw that we could do that. We can change a pointer to point somewhere else if it happens to be a non-const pointer. The other thing is that for references, you have to initialize them at declaration. You can't declare a reference and not initialize that. If you do that, you're going to get a compiler error, and we're going to see that in a minute. But for pointers, you can declare a pointer and not initialize it, and it is going to just contain a junk address. And if you try to use that uninitialized, you are going to be setting yourself up for trouble. So we saw that. So these are the main differences between pointers and references. And now we are just going to be looking at how these translate in code. Here is a simple example. We have a variable called double value, which happens to be double, and we have a reference to it and a pointer to it. So you already know these concepts. Now, if we want to read the value in here through our pointer and references, we're going to be using two different syntaxes. If we go through the reference, we can use this reference variable name directly and read the value or change it. And we can do something like ref double value to print that out. This is going to work. But if we want to go through the pointer, we will have to go through the referencing. And this is really bad. You know, sometimes people don't like this syntax. They think that it is not direct enough. So they prefer to use references to do these kinds of things. But pointers are still important, as we will see later as we progress in the course. So this is one difference. With references, you don't have to go through the dereferencing mechanism to use this star here to print stuff or even manipulate the data inside. You just use the variable name and it is going to work. With pointers, you have to dereference, because if you don't dereference, you're going to be referring to the address stored in this pointer. This is the first difference. And we see that the same applies if we are trying to write data into our variable. If we go through the pointer, we will have to dereference and use the star symbol in front here. If we are using a reference, we can do that directly as if we are modifying the original variable. So this syntax is much more readable. The other difference is that we can't make a reference something else, but we can change a pointer to point to something else. Let's look at an example here. We have ref double value, which is a reference to double value. And here we are doing an assignment to this thing here. We are saying either double value and assigning that to our reference. But what we are doing here is not making ref double value reference this other variable. We are just grabbing the value in other double value and assigning that to our reference. And the value in other double value is going to be reflected in the original value here. So this is what we are doing. We are not reassigning to our reference to make it reference something else. We are assigning the value to the reference as it is now. And it is going to be still referencing the same variable in memory. If you print out the address in memory, you're going to see that the address of the reference here hasn't changed. So this is something you should keep in mind. But we know that a pointer can point somewhere else. If we have a pointer here, for example, p double value, we can reassign it another address and make it point to that new address. So in this regard, we can think of references as const pointers, because const pointers can't also be made to point somewhere else. And if you try to do that, for example, here we have a const pointer. It is called const p double value. And if we try and make it point somewhere else through this assignment here, we're going to get a compiler error. Okay, so this is really all in terms of the comparisons that we had to make between references and pointers. Now we're going to head over to Visual Studio Code and see how these things work in real code. So here we are in our working folder. The current project is comparing pointers and references. We are going to grab our template files and put them in place. And we are going to open this project in Visual Studio Code like we always do. We are going to go down and put in some starter code, and let's align this a little better. And we can close this pane so that we have some breathing room here. We have a variable of double type, and we set up a reference to it and a pointer to it. This is how we do this, thanks. You already know this. And we can try and read through the original variable, through the reference, and through the pointer, and see how these syntaxes differ and how one might be better than the other. For example, if we look at how we are using the reference, it's really like we are using the original value here. We don't have to dereference. If we try to print the pointer directly like this without dereferencing, this is going to print the actual address stored in this pointer. It's not going to print the actual value stored in the address pointed to by this pointer. I really want this to be clear. So this is the syntax we can use for reading stuff, either through references or pointers. We can also use these syntaxes to write stuff into our variables. For example, here we can go through the pointer and we have to dereference, and we can go through the reference to really do the same thing. And we're going to see that our syntaxes here are going to pick up the changes regardless of whether we write through pointer or a reference, because all these things really are going to be referencing the same location in memory. Let's try and bring up a terminal here. And we are going to build with GCC. Let's do that. The build is going to be good, and we're going to clear and run Rooster. And you're going to see that at first we're going to have a 12.34 in. That's going to be the value. We can get it through original value, the reference, or the pointer through the referencing. And the address is this one here. If we change the value through the pointer, we're going to see the changes reflected here. And if we change the value through the reference, we're going to see the changes reflected in here. So this is how you can use pointers and references to do these things here. And you can really choose what makes sense for your application. They mostly do the same things. But some people say that the syntax to dereference the pointer here is really ugly. That's why most people prefer to use references like this. But references have other benefits as well, as we're going to see as we progress in the course. Another thing I want you to see is that you can change a reference to reference something else in memory. For example, here we have our reference, which is ref double value. If we try and make it reference something else, we're not going to get that result. Let's go down and try to do that. So we're going to set up another double variable. So if we try to make our ref double value reference this guy, the syntax that comes to mind is saying ref double value and assign that some other double value here. Now let's see what happens if we do that. We're going to try and print whatever we have in memory using the ref double value here. Let's grab this and go down here and say that we are changing the reference, making the reference reference something else. Let's say that. So if we try to build this, let's see what we get. We're going to run and build with GCC, and we're going to try and run this, clear, not clear, and we're going to run Rooster. We're going to see that the last line of output here says 78.45, but the address is still the same. So we are still referencing the same memory with our reference, and what we just did here was just grab the value in some other double value and assign that in here, but the reference is referencing the same memory location it's been referencing. So in C++, you don't have a way you can go through to make a reference reference something else. The only chance you have to make it reference something is through declaration here. And that's the reason you can't declare a reference and not initialize it. If you do that, you're going to get a compiler error. So let's try and do something like this. We're going to take out this double value. And the moment we do this, you're going to see that Visual Studio Code is going to be unhappy. You see the squiggly line. and it is going to say initial value of reference to non-const must be a null value. So what is that? Okay, if we take out the initialization altogether, it's going to give us a better error. I think reference variable requires an initializer. So every time you declare a reference, you have to initialize it. And we should do like we just did before here, and we're going to be fine. Again, you can't declare a reference and not initialize it. If you do that, you're going to get a compiler error. And the reason is that this is the only shot you get to make your reference something else. Okay, if there was a way for you to bypass this and let the compiler compile this, you would never get another chance to make this guy actually reference something, and it would really be a useless reference. So make sure you understand this. You can't make a reference something else. And if you try to do something through a syntax like this, you're going to be assigning the value of whatever variable you have to the reference. You're not going to be making the reference referencing something else. The reference is going to keep referencing the same variable in memory as we have seen here. So let's say what we were trying to do here, but we know that we can make pointers reference something else. So here we have a pointer again, this pointer called p double value, and it has the address of double value inside, but we can set up another variable. Okay, so we can make that reference this other variable here, and let's do that. You're going to see that our pointer now is going to be containing another address. So what we can do is say p double value, which is our new pointer, and we're going to assign it the address of some other double value. And if we print the data now and go down, we are going to say make the pointer point to something else. That's what we are doing here. And we're going to say the same thing here through a comment. And if we print this, try to guess what we're going to get. The pointer is going to contain a completely new address. Because we can do that, we can make it point to somewhere else. Let's run Rooster. And we're going to see our data here. Let's make sure we see the entire thing. Okay, I think this is the data we have. Let's go up again. There's no harm in that. So we have our things that we have seen before, but what is going to be important here is that p double value now contains a new address. Okay, so this is really important, and you have to understand that. So we made the pointer successfully point to something else, and if we change the data in the pointer now, we're not going to be affecting the data we have in here, in double value. We're going to be affecting the data we have in some other double value here. Let's do that. We're going to change the data through the pointer. So we're going to say p double value, and we're going to change this to 555.5. And now we can print the data and see that things have changed in memory. And we can print this to see the differences here. But before we do that, let's also print the address of the original variable and the address, because for now we are just printing only the address through the pointer. So what we can do here is grab stdc out and say address of double value, and we're going to put that out through stdc out. Okay, we're going to do that, and we're going to print the address of the reference. Why not? Ref double value, and we're going to put that out as well. We're going to say address of ref double value, and we're going to say std out, and after that we are going to grab the entire thing here and print it out after we modify the value in the pointer. I hope this is going to show things in a much more clear way. So we're going to build this with GCC. Let's do that. The build is good, so let's clear and run Rooster. And what you're going to see is that now the original variable is living at address here, which we can see in our reference, but the pointer now is pointing to something else. No wonder that the changes we did through the pointer are not being reflected in our double value, because these two variables now are living in different memory locations. I really hope you see that. And this is really all we had to share in terms of the differences between pointers and references. I hope you have a clear picture of what these two things are. And we are going to stop here in this lecture. In the next one, we're going to see how the const keyword works with references. Go ahead and finish up here and meet me there.